Good evening, everybody. Happy Thursday. Yeah, I gotta take the trash out. Yeah, during the break. Uh, yeah, trash takeout day. So let me get some whiskey real quick. If you don't mind. Yeah, I'm a drinker, so I drink. Uh, all right. So, uh, we wrote this special relativity disproof paper, right? So I submitted to a physics journal, and I got rejected. They did email me. Okay, so yeah, political science paper. Probably it's got rejected, but I didn't hear from them, so I'm assuming that they rejected it. So yeah, it didn't bother me at all. I mean, it's very well expected because the way I write is different from what scientists, professional scientists write. I'm amateur, and so it was very expected outcome. And yeah, it didn't bother me at all. Yeah, it's just whatever. But yeah, I thought it's kind of dumb, right? Because we disproved it. It's special relativity theory, and it's a big subject and big win victory, and they rejected it. So what does that tell me? They're not very smart people in physics. I'm sure some of them are. Okay, maybe some of them will pay attention to this paper because it's uploaded in the online database where the people can read it, download it, the PDF, right? So it's out there. So maybe some physicists are smart enough to pay attention to this paper. Yeah, for their own sake. Why? Because this special relativity has been with us since 1920s, I guess, when Mr. Albert Einstein wrote it and published it. Oh, give me 1 second. Let me. Yeah, I'm taking the terms. So, yeah, so physicists has been wrong when it comes to special relativity for 100 years. Nobody was able to correct. I guess there have been some attempts at disproof of Mr. Einstein's theory, but maybe our paper is just the latest attempt. But we succeeded though. Okay, and we did so in a very nice way. It's just that I'm sure there are some smart physicists out there, okay, but others not very smart, right? And I kind of feel sad because they're still studying the wrong theories, and they're studying it, and they're even teaching it. Special relativity by Mr. Einstein. And but we proved it wrong. And they're still studying it and teaching the wrong theory. That's a little bit sad, and that's very dumb. Not very smart, right? Yeah. Well, we do what we can, so that's fine. And so, in terms of general relativity, disproof, yeah, we're gonna construct sets and subsets. So you'll be set theoretical, all right? So because there's no other way around, right? So yeah. Well, let's bring back the whiteboard, okay? So that yeah, let's be visual. So yeah, we're gonna name these sets, right? Yeah, it's set theory. So if you've been here long enough, with in humanology series, humanological mathematics, right? We used to do a lot of set theory stuff, right? So yeah, we are no stranger to set theory. We love set theory, but Mr. Herr Georg Cantor, he's not one of the founding members of set theory. He kind of popularized it, but he's not one of the founding members. Like, but that's what I also thought that way. But I looked him up, and I realized no, this is not the guy. Georg Cantor is not the founding member of set theory. So that part of history is still being taught, like he's the one of the founding member of set theory. That's incorrect. Okay, so but that's how I was taught when I was in Seoul, South Korea, high school or middle school. Okay, but he's not the founding member, one of the founding members of set theory. Founding member of set theory is Peano, the Italian mathematician. Peano and Boole and some others. Yeah, but Georg Cantor his contribution to set theory isn't that big. He popularized it though, and also his theory about this transcendental whatever this like cardinality or whatever the infinite number is also wrong. Okay, and we did point out where he erred a long time ago here in the humanology series. Okay, about 5 months ago, I guess. Probably even before that. Okay. Okay. So we came up with a better idea. Now, but that's pure mathematics, though. Okay, so which nowadays we seldom do. Alright, so what do we have here? I'm looking for a better vodka because this is the spruce cones vodka. I don't quite feel like that today, so let me switch this out. So yeah, it says citizens, but they're just members of a set, right? And so you have first set and second set is and third set, right? And each set have set members, and the higher you go up the rank, the supersets of the sets below. Okay. So yeah, that's the subset, then superset, superset, superset. Okay, so you be like look like onion, kind of onion ring style. Yeah. It's because it's this. Mr. Einstein's his proposition was this. An observer cannot distinguish between the gravitational force and inertial force, the ethereal wind force. That's correct. But this same observer cannot distinguish gravitational pull and electric pull or magnetic pull either. Okay? Let's say I'm wearing positively charged clothing, right? And I'm in a room where uniform electric field is applied, like in a capacitor, right? So I will feel the pull because I'm wearing this positively charged clothing. So behind me is positively charged capacitor, half of it. In front of me, outside the room, okay? In front of me, there is this negatively charged capacitor plate. So I will, well, let's do it the other way. And let's say, okay, my clothing is negatively charged, okay? So then my whole body will pull back. Will I be able to tell the difference between that electric force and gravitation or acceleration force? No. I will not be able to tell any difference. Why? Because force is force. But then Mr. Einstein erroneously concluded that just because observer cannot tell the difference, those forces are equivalent. Big mistake. So bingo, we got it. We know now where he erred. Okay? Okay. Let us take 5 minutes break and then we'll continue. Yeah. Okay, we'll take 5 minutes. Haha. So yesterday, give me 1 second. I just pulled my trash can so that I don't forget taking it out next break because I forgot this time. Anyways, so yesterday I took a day off and now I'm very refreshed. So I think having a holiday day off is very important to maintain this energy level and whatnot. So yeah, it was very nice. Yeah, I feel very refreshed and kind of energized today. That's good. Yeah, so now we found where Mr. Einstein erred, right? In special relativity, the last section was about simultaneity. Okay, the way he erred is that he thought this speed of light as the gold standard of measuring simultaneity, but what we did instead is our alternative is this: pushing the rod or pulling the string. Okay, that's simultaneity, and speed of that signal, pulling the string or pushing the rod, that's the speed of that signal method is infinity, which is faster than speed of light, and that's the true simultaneity. Okay, so that was good. Yeah. So simple, right? Yeah. So yeah, I mean, all these physicists who went to Harvard, Yale, MIT, Stanford, okay, they are good learners, but they're not quite good independent thinkers, okay? So they just followed Mr. Einstein's line of reasoning, and they didn't find that objectionable. It's not that surprising. People are people, right? Yeah, they just follow the mainstream majoritarian view. Because not many people are strong enough to challenge this big, gigantic Goliathan, Mr. Einstein, because he's a big figure, right? Not many people have guts to challenge Mr. Einstein. Some of us do, and we are just that, okay? So, yeah, it's good to be us, right? Yeah. Now, so, I mean, secular people who read about Einstein, well, I'm one of them. I was, right? That's totally fine, right? Because it's not their profession. But physicists, it's their job to do it right, so they're not quite doing their job right. Okay, just like casting directors or Hollywood Film Festival, the judges, right? In film festival, the people who pick the what movies to display for the film festival, many times they are not doing very good job either. Or casting directors, like people in Hollywood or film industry, many of them are not doing very good job. Okay, because when I was in Hollywood, I mean Los Angeles, California, trying acting. Okay, I have seen so many beautiful, very beautiful, and handsome women and men, but they were having hard time getting acting job in a big screen. Okay, because yeah, Hollywood people they're not quite doing a very good job. Okay, because I mean when it comes to acting, acting is easy. All right. Acting is not an issue, okay? Then what's the issue? The way people look. That's talent. Because when we watch television, we want to see beautiful people, right? And also, it does serve some some social function too, role model, okay? Yeah, looking good is good, right? And good, the best thing, people can be very beautiful. Beauty, in humanology, beauty is not something you are born with. You learn to be beautiful. Like the way you do your hair, facial expression, there's something people can learn. The way they dress, right? Yeah. I mean, my parents always emphasize I have to have good facial expression. Okay, so my parents said, yeah, oh, my mom, very beautiful lady, my dad, very handsome man, okay, because they take care of their facial expression, clothing, and their smile, and so yeah, they do their hair, both my mom and my dad, okay, they take care of their appearance, and they educate us, their children, to do the same. So that's something we learn, right? I'm not saying I'm a handsome guy. I kind of like the way I look today. I guess I'm kind of refreshed over yesterday's day off. So yeah, I think I look fine today. And anyways, so but don't get me wrong. In film festival in Hollywood, like some of them are doing good job, but others don't. People are people, right? So, in physics, just like in anywhere else, any other industry or academia discipline, yeah, some of them are doing good job, some of them are not. E equal mc squared, that's the wrong equation. I forgot to say that in the special relativity paper, but I had to get it done and over with, even if it's not perfect. Okay. Maybe I mentioned that in general relativity paper. That's fine. Why? Yeah, I forgot to say that. But yeah, all the field equation in general relativity or black hole, or light bending, they're all fiction, they're science fiction, and they're all manipulated. There are nothing proved Mr. Einstein's special or general relativity because they are wrong theories. Hopefully, truth will come out eventually. Well, it is already out there. It's just that people, not enough people are paying attention to it. Okay, so maybe in the future, that would be nice. But it may not happen in my lifetime. Okay, so or it may never happen. I don't know. Jesus said, truth will eventually come out. That's what he said. I hope he's right. I hope Jesus is right. I hope eventually truth will come out. Maybe the paper we wrote together, special relativity disproof, maybe you will never see the light of the day. Never. That is possible. I'm okay with that. Because, and maybe somebody else just independently disprove Mr. Einstein and that person get famous. Maybe that person could be you. Feel free to publish and yeah, be famous. Okay, you don't have to mention me. When that happens, yeah, it's all yours. Okay, yeah, be famous. Okay, you don't have to pay me. You don't have to mention me. Okay, just go ahead, be famous. Enjoy your fame. That's I'm. Everything I do here, I give it to you for free. With knowledge sharing space. You pay me with your time, right? And I pay you back with some knowledge that I learned somewhere else or we did it together here. It's all yours, okay? So you don't even, it's not even necessary that you cite me or cite this, okay? Just don't lie, okay? What I'm asking is that when you write a paper, and if somehow I inspired you, and you inspire me too, it's mutual, okay? But you write a paper out of some inspiration from this, it's up to you whether you cite this or not. But what I'm asking is that just write a little footnote, okay? Yeah, I got inspired by somebody. Okay? That's what I'm asking, okay? Because I don't want you to lie, alright? But it's not necessary you mention my name though. If you want to, that's fine too. Okay? Because I'm quite a well-known figure, at least locally, okay? So my name is out there in the web because I ran for public office. This house's address, my cell phone number, my email addresses is all out there in public. Why? Because I ran for public office. And I have no problem. I'm kind of a public figure, okay? Well, at least locally, so yeah, you can mention my name, no problem. If you want to. Right? I'm not asking you to. It's up to you. Yeah. Okay. Yeah, we just do our job, right? Yeah, I do mine. So, yeah, I mean, electric force by definition, it only applies when this object has some non-zero net charge, right? Gravitational force by definition, it applies to some entity that has a mass. That's definition, okay? Accelerative force, inertial force, when an object accelerates, by definition, it applies to an entity that occupies a space. Like light wave. It has no mass, but it does occupy space. It's a wavelength, fixed, finite wavelengths and amplitude, right? Vertical amplitude, okay, like in this sine curve, right? Vertical amplitude and wavelengths, the period, right? Horizontal length from here to there, okay? Yeah, it's there in physics textbook, okay? So Yeah, this fixed frequency, right? Yeah. How many waves are there in per second, something like that, right? Yeah. So it occupies this finite space. Then is subject to accelerative force. But it is not subject to gravitation or magnetic force, electric force, because it has no mass. Does not have net charge. It does not have magnetism. All right, so that's why light does not bend in these lower level forces. Does light bend by uh, ideological forces? Oh boy, that's an interesting question. Well, ideological force, that's kind of a joke, a little bit. Metaphysics is kind of philosophy, right? Yeah, it's not quite physical force, okay? So it's more like a political joke, actually. So we'll take 5 minutes break and we'll think about it, okay? So I mean, you can, I don't know how push. Yeah, you can push the flashlight, right? I mean, even gravitation, you can, well, electromagnetism, yeah, you can change the location of this flashlight, angle of flashlight, right? But that's not quite what we're talking about here, okay? So, yeah, this is why I didn't start to write this paper yet, because it's too early. We are still brainstorming. We already published two papers, yeah? Political science and special relativity disproof. So, it's not necessary that we keep on publishing, right? We want our paper to be in high quality, and yeah, so that's why I didn't start writing te- this general relativity proof yet, because I'm not ready. So, all right, we'll take 5 minutes, okay? So let me think about it. Okay. This fourth, yeah, it's more than a joke. It's important. Fourth echelon, it's kind of important. So let's think about that, okay? So yeah. So, uh, when let's take a break from all this, okay, for a while, for a second. Uh, when so I made a movie, Therapy for Metrophobia, right? And then when it got rejected by big festivals, yeah, I was like heartbroken. It hit me pretty hard. And then later on, I kind of realized why was that the case? That was the case. Why they rejected my movie? I'm talking about big film festivals, okay? Because uh, they don't really gain anything by selecting my movie, okay? So it's kind of deal with controversial topics like religion and whatnot, right? And so basically, they're saying, I guess, what's in it for me? What do I get by selecting your movie for my film festival? There's nothing in it for me. So why should I do you a favor by selecting your movie? Yeah, I understand that because yeah, people they are all self-serving, which is not a bad thing. They're all egocentrism, right? Yeah, self-interest. This just how we are. So yeah. So casting directors, I guess they're pretty much the same way. I'm not saying all of them, but many of them. Maybe they see a very beautiful actor, I mean handsome actor, beautiful actress, right? Maybe somehow they may feel some jealousy about that. Okay, so that would be my guess. Okay, because acting, I mean, when you see a movie, do you really care how well this person act as an actor or actress? I don't. I just want to see handsome men, beautiful ladies in a movie. Acting to me that's very secondary. Acting skill is very secondary, and it's easy to learn. It's nothing really to me like really critical when it comes to movie or TV show. I want to see beautiful people in television movies, right? Because there are not that many, and I'm saying yeah, people are all beautiful, okay? No matter what body type they may have, they're all beautiful. But when it comes to a show like theater or play or the movie, TV, or a journalist in television, like in a news program, we rather see very beautiful people, right? Yeah. Or in politics, even. Okay, so yeah, whatever. So yeah, yeah. I guess that's why they rejected these papers that we wrote and I submitted because this is nothing in it for them, right? So and I didn't follow the formatting guideline. Yeah, I totally ignore that, and so I don't have time for those things. So and also publishing the special relativity disproof actually may not good for their career either, especially if they spend a lot of time advocating for special relativity. Yeah, that's fine. And they have to feed their children, kids, pets, pay the mortgage, so I understand that. People are people. Yeah, so Mr. Jesus, the way he criticized his competitors like Pharisees, Sadducees, and synagogue leaders of his time, uh, he didn't quite walk the talk because it seems he really hated them. So it seems he hated his enemies. Okay, he didn't quite walk the talk. Okay, so uh, because the Jewish synagogue leaders of his time, like church leaders, were synagogue leaders of his time and his locality, they saw Mr. Jesus as a threat, as a strong competitor. Because if people follow Jesus, his brand new religion, Christianity, then they will stop going to the traditional Jewish synagogues. So they were competitors, okay? Jesus and others. They are competing for people, people's money, and people's attention, people's time. It's religion market, all right? Uh, it's just one way to look at it, all right? It is market competition. And did Jesus take money from people? Yes, he did. He took offerings. It's in New Testament, okay? Yeah. Did Jesus take money from poor widow? Yes, he did. Would you have? I wouldn't. Yeah, this poor widow had 1 penny left. That's all she had. She gave it to Jesus, and Jesus, yeah, he took it. Hmm. Right? But at the same time, Jesus criticized other people who did the same thing. But he did the same thing too, Mr. Jesus. Jesus criticized some other people, like some wealthy individuals who swallow up poor widows' meager asset. He did criticize that, but there's difference, right? Yeah, Mr. Jesus, he took the money because the poor widow voluntarily give that penny that she had, 100% of what she had to Jesus, right? But other like businessmen or some wealthy people that Jesus criticized, I don't think they stole that money from widow. Probably they stole something. Maybe they are lenders, money lenders, so who lend money to the poor widow and then take the interest and principal. Okay, yeah, like home closure, well, foreclosure kind of situation. Okay, so yeah, I mean, Jesus kind of criticized that, but well, it was not exactly involuntary theft. What was that? I guess it's higher interest rate when they lend money to people with not so good credit, right? Yeah. So it wasn't exactly theft. Yeah, so we do have some criticism about Jesus, okay, Mr. Jesus. Yeah. But yeah, he also said something like to Peter, right? Hey Peter, after he resurrected from death, he said to Peter, when you are young, you can go anywhere you can you will be able to go anywhere you want to, Peter. Okay, but when you are old, yeah, people will spread your arms and take you to somewhere that you don't want to go to. That's what Jesus said to Peter. Okay, I don't like that. That's not nice. Okay. That's very grim prediction of his favored disciple. So I don't like that. I would have to say no. If Mr. Jesus said that to me, Mr. Jesus, well, I object. I'm sorry. Okay, so I have to say no. Alright? That's very pessimistic kind of attitude from Mr. Jesus, so I don't like that part at all. Alright, so and I don't believe in that part. So in humanology we do criticize big figures. Yes, even Jesus. Even Bible God. Right? How about Buddha, Confucius, Muhammad Allah, or Socrates, Plato? Do we criticize them? Not very often. Why? Because I don't know too much about them, all right, but I know about Bible, so yeah. And other religions doesn't play too big a role in humanology, okay? Not nearly as much as Christianity. It's just because I have Christian background, that's all. Yeah. Anyways, ideological force. That's kind of tricky. We'll not talk about this then, okay? So, yeah, let's just focus on this physical force first, right? So it's about this members of this sets, right? Yeah. We want to come up with very consistent and coherent schema of things, you know. Okay. Ethereal wind and a photon. Okay, let's think about that. So we are breaking away from special relativity. So there's no such a thing as maximum speed. Well, the maximum speed is infinity, instantaneity. Okay, or this string pull string, push the rod. The signal speed of that is the infinity. Okay, so well, which is maximum infinity. So in other words, there's no upper speed limit in nature. Okay, speed of light just happen to be something very fast, but at least in theory, yeah, speed of light is not maximum speed in nature. Okay, so we are breaking away from special relativity. Okay, yeah. All right, we'll take a break. Okay, all right. So, all right. Okay, so let's take a break from all this. Okay, so yeah, let's talk about beauty. So I mean, I do my best. I'm not saying I'm good looking or anything. I do my best to look nice. Yeah, it takes effort, right? Personal hygiene. Yeah, I take a bath before I go to work, Monday to Friday, right? Yeah, being clean, it has to do with ethics, not aesthetics. What? Aesthetics, right? The philosophical inquiry about what beauty is, aesthetics, right? Yeah. So to look good, it has to do with personality as well. Okay, people who are nice, agreeable, who are kind, they tend to be better looking. Okay, and also, yeah, being generous and kind to other people, they tend to be better looking, right? Because they're happy, right? So, because they're happy. Why? Because everybody loves them. Because they are nice. You make them happy, right? So if you're nice to other people, more giving, generous, and you're hardworking, so you have a lot to give. We are not talking about money. We are talking about copium, all right? What is copium? Well, one way to think about it is happiness. Okay, so you work very hard, so you are happy because you pay all your bills, and you get to save. So and also, yeah, right. So yeah, do diet, exercise, of course. That does take effort, right? So and you're nice to people because you can afford to be nice. Why? Because you're happy. Why are you happy? You pay your bills. You work hard. You pay your bills, right? And you got some left. You take a good rest, and yeah. So happiness. So you're happy, and you look good. You make other people happy, so people like you. They enhance your happiness as well, right? And then yeah, you do something that is ethical and legal, right? Moral. Yeah. Yeah. So personal hygiene and whatnot, right? Good nutrition, good rest, and good ethics. You're nice to people, right? Yeah. Then you'll be a very beautiful person, right? Now let's get back to this. So ethereal wind force, accelerative force is this, okay? You're in a jet, it's taking off in the runway, in the airport, and when you're accelerating, it's as if the rest of the world is going backward when you are standing still, right? Let's say an object, rocket in space, is accelerating, okay? And let's say inside of the spaceship there's just an object, but not people, okay? And inside of this spaceship is vacuum. There's no air, right? And when this rocket accelerates, this object in this rocket, there's no air, okay? But it starts to pull backside of this rocket, okay? As if there's some wind force coming toward this object. As if the entire universe is accelerating backward when this object is standing still. Right? So that kind of wind analogy is the ethereal wind concept in our framework. Right? Now, let's say, so photon in our paper is this, okay? Previous paper. Photon does not have to be moving, okay? It does not have to be moving. I mean, if we flashlight or laser beam when we are standing still, yeah, relative to us standing still, Yeah, it has this speed of light, of course. Okay, but if speed in our framework, speed is all relative. Okay, so if this rocket is just moving in a constant velocity, okay, compared to Earth, whatever, yeah, you can have speed of light. Okay, and let's say uh, I'm trying to design a sort of experiment where a rocket or some object in space, like it could be meteorite or it could be whatever, that is traveling at the speed of light. Okay, let's say um, this big explosion. Okay, like Big Bang, whatever. So let's say the sun. Okay, okay, sure. Some projectile from the sun or some star or whatever. Okay, so in some kind of cosmic explosion. It going two objects are going that way. Okay, so according to object A, object B is going at the speed of light. Okay, so in object A, uh, shoot out a photon that way. Okay, so uh, yeah, whatever. So let's say hypothetically, okay, photon is inside of this spaceship and is standing still because this spaceship is also traveling at the speed of light. Okay, so photon is this like passenger in this spaceship that's moving in constant velocity, speed of light. Okay, now can we contain a photon? Yes. Light has both particle property and also wave property, right? So it's a dual property. So photon is kind of an analogy, okay? So it doesn't quite exist. It's a model, right? Okay. So you have electromagnetic wave, right? But once photon move from sun to planet Earth, right? It does not quite leave the trace behind it though. Okay? Yeah, it does move in an electromagnetic way, but once it's gone, it does not exist in the past trajectory that it traveled before. That photon is gone. Right? So yeah, it does not leave any trace when photon travels in space. Okay? When we turn on the flashlight in the air, you can kind of see that, right? It's because photon is constantly being emitted out of this flashlight. Okay? And some photons disperse or get absorbed by the air. So that's what we see, this sunbeam or flashlight beam in the air. This all this sky show, right? Whatever at night. Yeah, like Batman movie, right? Yeah. Yeah. So okay, so in this spaceship, photon is the passenger, okay, and this spaceship is moving at the speed of light, but and it's moving in constant velocity, so photon is the passenger, okay. Yeah. Now, once this spaceship start to accelerate, yeah, the photon will pull back, so it is subject to ethereal wind, okay. Because photon does occupy a certain space, it's a fixed wavelength and amplitude. Okay? But it has no weight. That's why it's not going to affected by gravitation. But it does get affected by this ethereal wind force, which is accelerative force. Okay? Mm-hmm. Yeah. But it's not subject to this push force because to push something that object need to have some kind of mass, volume, right? Some physical existence. Well, photon also is physical existence, but it has no mass. That's why you cannot push your photon away or blow it away in air wind. Okay, but okay, we'll take 5 minutes break and we'll talk about speed of uh, force field. They say the force field, like electric field or magnetic field, the speed of force field is speed of light, and that is wrong. Okay, then what's the speed of electric field or magnetic field? Let's say you have shield and you lift up the shield, and with what speed is electric or magnetic force field travel from A to B? I'll leave you with that. We'll take 5 to 10 minutes break, okay? And then we'll answer it together. Okay? All right. Thank you.